name's Neil Sewell. I'm from Theta Technologies. We do sensitive non-linear test equipment for non-destructive testing. It's designed specifically to answer some of the challenges of additively manufactured components and high-value manufacturing. So the challenge with the ROBOTT-NET project was that we have some very sensitive equipment, and we have a patented technique to enable us to determine whether the equipment's being applied correctly to a sample. However, we didn't have the robot expertise to be able to join this up in some kind of feedback loop.
So NTC's role in this project has been to provide that robotic experience and expertise and to assess the manufacturing process to see its feasibility.
Prior to the ROBOTT-NET project, we were utilising a manual process to guide the robot along a certain path to do the testing, and utilising this technology now we can apply the force feedback system and our coupling contact feedback system to allow the robot to much more accurately guide the tool along the path necessary for scanning a component. And this means that going forward we'll be able to test much more complicated components, much more complex surfaces, and determine with a high degree of reliability what's wrong with the part.
So in the voucher process on the MTC side, we've developed a demonstrator to investigate actually the robotic control required for the manufacturing process. So currently their end effector isn't fully realised, so we've had to do a sort of a simulation of their end effector in software and actually try and see what level of control we can get from the robots.
As a result of the voucher process, the technology that's been demonstrated has been a system of feedback that allows the robot to manipulate our head in 3 dimensions and to determine, given simulation, the amount of force that's being applied to the transducers within the head. And that's really useful for us because as we take this further forward, we will be needing to have the real world contact measurement and sensitivity equipment connected up with the robot to allow it to drive things, drive the system along to measure the complex surfaces that we're looking at. So the output of ROBOTT-NET has been really useful for us, and we're hoping that we'll be able to utilise this technology development and subsequent developments to enable us to apply it to a whole range of different materials and different complex surfaces and geometries. The market research that was done by Technalio as part of this project has demonstrated that there's a need for what we've got and the application of the transducers and equipment and all of our techniques to additively manufactured parts, high-value manufactured parts, and to some of the challenging situations that modern manufacturing finds itself.